Okay, now if you want to do the partial fractions with the repeated linear factors, so the repeated linear factors in this case is this x minus 1 square, because then there's an x minus 1 and then there is another x minus 1. So there are two x minus 1s at the denominator. The way we actually do this partial fraction is we need to convert. There is no way we can integrate it that way, so we need to actually convert into partial fractions. So the way we do is we just do 1 or a divided by x minus 1. Then we do b divided by x minus 1 square plus c divided by x plus 1. The reason we wrote x minus 1 and x minus 1 square because that was a repeated fraction over here. Once we got this thing, we need to make the denominator same, all the denominators same. So if you have a look at the bottom one, this is x minus 1, this is x minus 1 square, and this is x plus 1. So what we do in this case is we just see what is missing. So I'm just going to write it down at the bottom. You can write down the whole of these denominator, x minus 1 square and then x plus 1. Now on the top you just got a. Now here I need to make it that one, but what is missing? There is x minus 1, there is another x minus 1 missing, so I write x minus 1. What else is missing? X plus 1 is missing. Yep. So I got that one. Now look at the b. Let me change the color for the b. The b is here. Now what is missing? X minus 1 square is there at the bottom. So what's missing at the bottom? Just x plus 1. We're not writing at the bottom, we are writing at the top. So now let's look at the next one, plus c. Now x plus 1 is there, so what's missing on the top? X minus 1, x minus 1 whole square. So now we got this thing, and that thing is actually equal to this bit. But if you have a look at the denominator of this thing and the denominator of that thing, they are similar. So you can just cross this denominator and cross this denominator, and you will have 1 equal a x minus 1 bracket x plus 1 plus b x plus 1 plus c x minus 1. Because the fraction will only be equal if the denominators are same, the numerators have to be same. For example, let's say the denominator here is x and the denominator here is x, and on the top that's here 1 plus 3x, let's say. They will only be equal if here, whatever here is equal to 1 plus 3x. Otherwise, they're not going to be equal. If the denominators equal, numerators have to be equal to make the whole fraction same. Otherwise, they are not same. Once we got this bit, what we're going to do is we are going to cross the denominators. Because they are same, we can cross the denominator. Other way of doing that one is bring this denominator on that side. When you bring this denominator on that side, it will multiply. So the bottom and the top, they will anyway cancel out. Now what I got left? I only got left with the numerator part, that part, which is 1 equal a x minus 1 x plus 1 b x plus 1 c x minus 1 square. Now what I need to do is I need to open this one up. How I can open that brackets up? I'm just going to multiply this x times x is x square. I'll leave the a outside for a while. X times 1 is x. That's, yeah, I can use the FOIL method, yes. And I will get an answer. Then I multiply with the a as well. This one I can straight away do bx plus b. This one I need to open that one. This is not going to be x squared minus 1 square, because this is x minus 1 and then another x minus 1. So when you multiply that thing, that will become a x minus 1 bracket bracket x minus 1, and then you just do this and that, all the multiplication, and you will get an answer. Now remember, c is already outside, so what we're going to do, go back, okay. Now here when I multiply, I got x squared minus 1. Here when I multiply, I got bx plus b. Here when I multiply, I got this thing, x minus 1 will convert into x squared minus 2x plus 1. When I multiply the a inside, that will become a ax squared minus a. Yeah, so ax squared is here, minus a I'm writing at the other side. Yeah, and there's a reason I'm writing at the other side. Yeah, it's still a one straight series of term, one equation. Now that will become a bx, so I write the bx here, I give a little bit space, bx here, and then b times 1 is just a b. I wrote the b on the other side here. Now I need to do that one. C times x is cx squared, I write that one here. So I'm writing all the x squared together, and c times minus 2x is going to be minus 2cx, and I'm writing everything that has an x together, and c times 1 is just a c. Once I got that bit, these are the terms with the x squared, these are the terms with an x, and these are the terms with no x. So this is the constant term, this is the term with an x. What I did here, I took the x common. If I took the x common, I'm left with b minus 2c, which is here. Here on this one, I took the x squared common. I'm left with a plus c. There is only one here. On this side, there is no x. There is no x squared. But there is actually, but we can't see because it's a 0x squared and a 0x. Why I want to add this 0x squared and 0x? Because I want to match the coefficients. Okay, now what does it mean? The term is only going to be equal if the 0x squared is equal to a plus cx, which means a plus c should be equal to 0. So I wrote that thing here. Now also b minus 2c should be equal to 0 as well. And also a minus a plus b plus c should also be equal to the constant, which is just a 1. Now I got a plus c equals 0, which means a equals to minus c. Don't worry about that one. We haven't done that one yet. It's on the next step, and I just bring it back and put the value. So a equals to minus c, but I don't have the c, I don't have the a, I don't have the b. So what I'm going to do, I will try to match the second coefficient, this one, and I will see what happens. No, back. Okay, let me do that one here. Do this one is, you wrote all the equation, not with the matching the coefficient one, the other equation, this one, again here. Then what you do is, you just assume, you just make an assumption. Let x minus 1 equal 0. Why let x minus 1? Because if you have a look at this is x minus 1. I'm just going to pick up the factor and make it equal to 0. This is known as the factor theorem. So I'm just going to call x minus 1 equals 0. If x minus 1 is equal to 0, what's the value of the x? It's going to be equal to 0 if x equals to 1, because I can move this thing here, and that's the answer. So I got these two things, and now I'm going to put it back in this equation. So I'm just going to put here a, x minus 1 is 0, so I'm going to put a 0. Yeah. When I put a 0 here, instead of x, I just put 1. Yeah. So that will become a times 0 times 2, which is just going to be a 0, isn't it? Because a times 0 times 2 is just a 0. Now here, plus b. And now I got x plus 1. Now here, I got x. Let me rub this one because that's the one we're going to do next. Okay, now this is x plus 1. Now value of the x, I'm putting 1. So b 1 plus 1. 1 plus 1, that will be b 1 plus 1 here. Now then c, x minus 1 equal, I put 0. So instead of that one, I'm just going to put 0 square. So what will actually happen? A times 0 is a 0. C times 0 square is just a 0 as well. And that will become a 2b. 2b equals 1. So b equals half. So now I got the value for the b. Once I got the value for the b, I still need to find out the other values. To find the other values, what I'm going to do is, let's change the color. I did x minus 1 equals 0 here. Now I'm just going to do x plus 1 equals 0. Let x plus 1 equal 0, which means the x equals minus 1. Now x equals minus 1. Now I'm just going to put that one. Wherever there is x plus 1, it's going to be 0. So that side is 1. So I can write 1 equal. That's a. There is a x plus 1. So that will become a 0. 0 times that is 0. So that will be just a 0. Plus b. X plus 1 is 0. So I'm going to put a 0. And then plus c. X minus 1. What is x? X is minus 1. So x is minus 1. So that thing will become a minus 2. When you write that one, make sure you write down minus 2 and then put a square. So what will happen? So now I got x plus 1 equals 0. Now when I did that one, this thing will become a 0, this thing will become a 0, and this thing will become a 0. And I will get 1 equals to 4c. Which means the c is going to be 1 over 4. Now I got like this answer for the c, answer for the b. There is no way I can get an answer for the a because that automatically turns 0. So to get an answer for the a, what I do is I go back to this one, because I got a equals to minus c. The c, what was the c? 1 over 4. So that would be minus 1 over 4. Now, once I got the value for the a, the b, and the c, what I will do? I will go back to this equation where I start doing the partial fractions. The a was minus 1 over 4, b is 1 over 2, c is that one. I put, instead of a, I put 1 over 4. And you can see there's a negative as well, negative 1 over 4, yeah? Instead of b, I put 1 over 2, yeah? Instead of c, I put 1 over 4. And because in the question asks you to integrate. The question was asking you to integrate that thing. So I'm just going to integrate one thing, this one, and integrating this thing, and integrating that thing. The way we integrate is 1 over 4 comes out, minus 1 over 4 comes out, and integrate that one. The way we integrate 1 over x minus 1 is the answer is ln x minus 1. And 1 over 2 comes out, and you got x minus 1 square. The way we can do integration, there's difficult way to do that way. So the best is bring it up. That becomes a x minus 1 to the power of minus 2. And then integrate it. The way we integrate it, it's minus 2 plus 1 divided by minus 2 plus 1. So that will become a x minus 1 divided by minus 1. This minus 1 will make this thing as a positive. Then I got 1 over 4 here, and then that will become a ln of x plus c, x plus 1. And we need to put this c, which is a constant of integration. If the question is like that, 1 over x plus 1, what's the differential of x plus 1? Just x plus 1. Differential of x plus 1 is 1, isn't it? And if the differential of this, not integral, differential of this thing exists on the top, the answer is ln x plus 1. Yeah. For example, let's say we got 1 over 1 minus x. 1 minus x, what's the differential of 1 minus x? Differential of 1 minus x is minus 1. But over there, it's not minus 1. So I can make that one minus 1, but I have to do minus here as well. Yeah. See, and that is 1 minus 1. Then I can call this thing as minus ln of 1 minus x. Obviously, you're going to put the c here and the c here. This is one example, and the bottom is if there's a negative thing there.